So I'm going to be talking to you about the work that I've been doing for the past 7 or so months, looking at the assessment of the immunomodulatory potential of far-UVC in keratinocytes. So I don't think I need to cover what far-UVC is. So ultraviolet radiation modulates the immune system in a number of ways. This has been covered in several review papers, but generally it's been recognised that UV exposure in the skin results in immunosuppression. What we don't know is the extent of immune modulation by UVC, particularly far-UVC. But we do know there are chromophores in the skin that upon exposure to UV radiation then initiate several immunomodulatory effects. So of interest to us is the chromophore urochronic acid. You may have heard of it. It's present in the stratum corneum in high concentrations. It exists as the trans isomer, and upon exposure to UV radiation, it's converted into the more biologically active cis isomer, which then initiates several immunomodulatory effects, as well as helping to prevent further DNA damage from reaching the dermis of the skin. Now, the mechanism of cis-UCA-induced immunosuppression has not been fully uncovered yet. However, a number of studies have investigated these potential mechanisms by investigating either the administration of exogenous cis-urochronic acid in vitro, so in cells, or by investigating epidermal cis-urochronic acid in vivo. So the keratinocytes in the stratum corneum absorb far-UVC. The amount that gets beyond this layer has been suggested to be less than 1%, up to around 15%. So despite this wide-ish variation, this is still a small amount when you compare it to other wavelengths in the UVB or UVA region, so you must take that into consideration. But it's still necessary that we investigate whether far-UVC has any other effects besides what we already know from the literature. DNA damage is not the only safety concern that we should have. So why is this also important? Well, I'm sure we all know and can appreciate that the immune system is essential in your resistance to pathogens, infections, but also just in maintaining homeostasis. So a normal immune system will respond by protecting the body. However, a dysregulated immune system in a disease state, particularly when you add that extra inflammation, it's obviously going to progress and contribute to disease aggravation. So it's really essential that we investigate whether far-UVC has any possible immunomodulatory effects in normal skin cell types. That way we have a baseline of the mediators or mechanisms that we can then translate into other skin models. So what we are primarily interested in at this moment in time is the cell-mediated immune response to far-UVC, particularly in the context of cis-urochronic acid. So we did this work by using an in vitro simplistic model. So this is just a monolayer of primary keratinocytes. And we use these cells because, to the best of our knowledge, this work hasn't actually been done before. And it's also going to be helpful when we translate this work into whole skin models. The first question we had is, does far-UVC alone generate an immune response, and to what extent? Then we needed to see if this is actually biologically significant. So expose our keratinocytes to solar simulated radiation, because we know that this produces an immune response within the skin. And so now we've got our two positive controls. We've got our, this is why I brought water up. So we've got our exogenous application of cis-urochronic acid in keratinocytes, plus our combined exposures with trans-urochronic acid and solar simulated radiation. So this was to see what sort of immune response we can expect to see, as well if there are any differences between cis-UCA alone or with our combined exposures. And then finally, what we're really interested in, does far-UVC convert trans-urochronic acid into the more biologically active cis-urochronic acid? So this will be a baseline, our baseline for measuring the far-UVC-induced conversion of trans to cis-UCA in a monolayer of primary keratinocytes. Unfortunately, I don't have all the results today. This has been a stepwise process. This is where we are right now. We have our UVC-exposed keratinocytes, our keratinocytes exposed to solar-stimulated radiation, and keratinocytes have been incubated in cis-urochronic acid. So we conducted this work using the UV Medico far-UVC device, which peaks at a wavelength of 222 nanometers, whilst the longer wavelengths are filtered. So we exposed our keratinocytes in a Petri dish to the far-UVC light source, and we allowed these cells to incubate for 24 hours. And the first thing that we needed to do was to determine cell survival. Now this was to identify suitable irradiation parameters where we can investigate these far-UVC driven cellular processes in cells that are actually alive. And then we collected the protein and the cell culture supernatant, and we used the protein for the cytokine antibody arrays. So we use this as a broad screening method. So this is essentially a membrane with 80 cytokines bound to it. You incubate your protein sample on it, and you can see the expression levels of these cytokines. And then what we wanted to do with these results is to take a couple of the upregulated cytokines and measure them in isolation using Western blot ELISAs, and to compare them with our solar irradiated keratinocytes and with our cis-UCA results. So we did a cell survival dose response in our primary keratinocytes with far-UVC at doses from 0.73 to 230 millijoules per centimeter squared. So your cell titer glow measures metabolic activity by binding to ATP, which is an energy molecule. So a decrease from 100% correlates with a decrease in metabolic activity. And then we multiplex this assay with cell tox green, which measures cytotoxicity by binding to DNA of cells with a disrupted membrane. So these are your dead cells. So you can see that the levels are more or less consistent, parallel to each other. So an increase from 0% with the cell tox green correlates with an increase of dead cells. So we found that doses less than 7.3 millijoules per centimeter squared resulted in more than 80% cell survival. So these are the doses that we took forward. And then we just wanted to confirm that apoptosis is actually occurring at these higher doses. So we measured caspase-3-7 activity. These are the executioners of programmed cell death. And you can see at 7.3 millijoules per centimeter squared, you begin to get increased levels of caspase-3-7 activity, which complements our cell survival results quite nicely. So we know that apoptosis is definitely occurring at these higher doses. So this does not mean that if you're exposed to these doses that it's harmful to your health, just that this is the criteria that we set to investigate these processes in cells where cell viability is maintained. So as I mentioned before, we use the cytokine arrays as a broad screening approach to analyze the cytokine profile of UVC-exposed keratinocytes. We also did this with the solar irradiated keratinocytes and with cis-UCA. I haven't been able to show those results to you today, unfortunately, due to a lack of time. But with the UVC-exposed keratinocytes, these are the doses where complete cell viability was maintained. And you can see with the fold change, it's not very high. It does increase with increasing UVC dose. There's also a change in the cytokines. There is some consistency with the upregulated cytokines. But what we really wanted to do with these results is take a couple of these upregulated cytokines, measure them in isolation, compare them with our solar irradiated keratinocytes and with cis-UCA, and that way we'll be able to see if any of the similarities or differences are biologically significant. And we're also interested in any dose-dependent increases or decreases. That way we have a reference to look back to for our far-UVC and trans-UCA combined exposures. So the IL-1 family is constitutively expressed in keratinocytes. Here we have interleukin-1 alpha, interleukin-1 beta, And what we generally found was that the UVC-exposed keratinocytes produced a very similar response to the solar-irradiated keratinocytes, particularly with interleukin-1 alpha. You can see expression peaks at 2.3 millijoules per centimeter squared, which is identical to the 0.1 SED of solar-irradiated keratinocytes. IL-1 beta, on the other hand, you get a dose-dependent increase with the UVC-exposed keratinocytes, with levels more or less consistent with ICFUST, but you still get that same trend with the solar-irradiated keratinocytes. So we took some other cytokines that we knew were upregulated from the literature, as well as what we got from our cytokine array results. And we found that with interleukin-6, very similar to interleukin-1 alpha, you get the same peak at 2.3 millijoules per centimeter squared, which is identical to 0.5 SED. IL-8, on the other hand, you get a dose-dependent decrease in secretion levels. It doesn't change much from the control, whereas with macrophage inflammatory protein 3 alpha, you get a dose-dependent increase in the UVC-exposed cells, with levels again more or less consistent with ICFUST, but you still see that same trend beginning to form with the solar-irradiated keratinocytes. So these cells, like every other cell, are multifunctional, so it's hard to say exactly what these trends mean. But the point that I really wanted to get across is that the UVC-exposed keratinocytes with the cytokines upregulated produce a very similar response to the solar-irradiated keratinocytes. So to conclude, as I just said, the UVC-exposed keratinocytes produce a very similar immunological response to the solar-irradiated keratinocytes. What I will say is, with the solar-irradiated keratinocytes with the cytokine arrays, you do see a lot more upregulation compared to the UVC-exposed keratinocytes. I couldn't show those results today. But now we have this work established, we're going to use it as a reference to refer back to for our future combined exposures with far-UVC and trans-UVA. And then, of course, we want to take this work into whole skin models, ex vivo, and then eventually in vivo. Thank you, everyone, for listening, and special thank you to my UKHSA colleagues, and ICFUST for the Young Investigators Travel Award.